Okay, good evening, everybody. So let us start our class tonight. Actually, we are in the second half of this course, and you know that tomorrow is 27th, is the due date to withdraw your course if needed. Then first year experience on the schedule page. And hopefully you will see your grade on Grayscope by tonight, okay, or tomorrow morning should be. I have completed my part, okay. So let us see our schedule. Our schedule is, we are in the second half. We completed recursion, and then this week we will start linked list, okay. And we will start linked list, and then there are two classes. Due to my family issue, I wanted to skip this course class tonight, but this is an important topic. So today's topic is the foundation of all of this, like this week and next week: stack, QE, linked list, stack, and QE. Okay, so if you understand linked list, then it will be easier for you to understand stack and QE operation. But if you do not understand linked list, you will not understand anything. You will not understand stack and QE as well as. Okay, and then due to time limitation, actually I'm not able to go everything twice, so I'm saving some time. For instance, I submitted a video in your section. You will see that is called what is called test to review. Test to review. Maybe you should see a video. This one, test to review. Maybe this one. This one. Test to review for abstract class, interface, polymorphism, and string operation. Please watch this video. Okay, and do practice. And I believe you may get at least 2 questions from this video. Okay, so if you watch this, then you should understand. You should get 2 questions for your final from this video, and actually that's what we covered in test 2. Okay, so since I have limited time, so this is why I'm not going this again with your section. Okay, but watch this video please, and write a note on your notebook, that footnote that you will get some questions from here in this video for your final. And then if you do not understand anything, actually, I am shocked, because I saw that many of you did mistake in string operation. I discussed string operation thoroughly in both sections, in your section, but some of you did mistake in string operation. I did not expect that. I thought everybody would be able to do that. Substring method, I discussed that. String length method, I discussed that. Most important, we get substring and string operation. But many of you did mistake. Okay, so let us start our topic tonight, linked list. Okay, so you see the title is called linked and list in plural. Okay, so let us start with list. What is a list? Okay, so list is like an array. An array is a list. A set is a list. Everybody understand set, right? Set is a collection of some similar object. It can be a set of friends, it can be a set of coins, it can be a set of books, set of pens, right? That means the main difference between a set and a list is that a list may contain duplicate elements, same element twice, 3 times, more than 1 time. But a set does not contain an element more than 1 time. That is the main difference between a set and a list. Okay, in C# and Java we say array. Array is a list. Okay, And in Java and C# there is another kind of built-in. Actually, it can be a collection. It's a type of collection. It can be used set. So when you declare a set as a list, then you cannot, as a collection set, then you cannot have duplicate elements. But if you declare a list, then you may have duplicate elements. So and another thing that you should see all of your resources on the first year experience page, resources page. Okay, resources page, you will see all of your labs here, and you will see all of your lecture notes as well as somewhere in this page. Somewhere you should see the slides repo. Then you should see all of these lecture notes. Okay, so today's is linked list. Okay, I don't know which one is added here. Okay, so is _mh is my version that I, based on my experience, I made some recommendation to make some updates. So they accepted this, and then they put my version. So I think that is them. So let me start with linked list. This one. So let us start with the title. The title of this chapter is called linked list. Okay, so what is meant by list? As I just told you, a list is a collection, a kind of set that may contain duplicate elements, right? That is a list. Okay, array. Okay, so array is a list. Okay, and so as I believe everybody knows about how to declare an array, how to assign value for the array elements, and how to access array elements, right? How to do operation on array. So those kind of array is called static array. Static array means that once you declare an array with a fixed size, then you cannot change its size while running your program. Okay. For instance, if you declare an array with 10 elements, with size 10, then but later if you think that okay, you have 11 elements, one more elements, okay, so then you have to create another array, and you have to move all of your elements from your old array to the new array. That is time consuming. Okay. Another similar limitation, think about that. If you declare an array of 1,000 or 10,000 size, but you see that ultimately you have only 10 elements or 100 elements. So then there is a possibility that you will have a lot of memory space unused, right? So you cannot use that memory space for other programs. Okay, that is a limitation. That is a limitation of static array. So in order to resolve that limitation of static array, there is a built-in array, dynamic array in Java, in modern programming languages, have incorporated a dynamic array. It's called it's called ArrayList. Okay, so actually that is under collection. So if you do a Google search and say for instance ArrayList in Java, ArrayList. Okay, ArrayList in Java or maybe in C#. You see, if you search for ArrayList for Java and C#, you will see that there are a lot of videos. There are a lot of online resources. This is the W3 schools, and then Oracle Docs. It has the API, and for instance, if you go to this site, Greek, many other sites. Okay, so for this is all of the sites. I request all of you to do some practice from these videos, from these resources for ArrayList. It's very simple. Okay, if I would get an hour, then I would be able to complete all of this, but I believe at this point, everybody, if you spend some time, then you should be able to do this operation like array list. An array list is a dynamic array. The advantage of the array list is that when you declare an array list, you do not need to fix its size. For instance, this is a public class array list. Okay, so I'm trying to copy this. Let me show you how to copy. I'm sorry. Maybe here. How to copy a program. So if you see a program like this way, for this it has a main. So let's copy this code, Control C, and then go to your Eclipse, and then go to your project. For instance, here, right? This is array. Maybe I can say my computer is slow. I want to create a what is that called, package, name ArrayList. I'm sorry, computer is getting slow. So new I want to click on new package, ArrayList. I got my package, and then within my package I have copied this code, right? And I will just paste, Control V. And since it has a main program, my code, you see that my code has a main program, right? You see that it has main method. So it is a complete program. It's supposed to be a complete program. Then once I click here, I paste here, that you see that it will automatically, sorry, it needs to be built 100. It will automatically create a class, and then actually I need a public. Just add public, and initially it is. I'm sorry, my computer is getting slow. I was supposed to restart it. Is building a workspace. So it is showing some error message, but we can fix it quickly. So one of the advantages is that copying and pasting code, that you don't need to create your class name, right? If you see a class, then you can copy and paste. Then it is showing error here, but here maybe it should go in one line. This is why. Okay. This is why. And another thing that I need to add is a Control +1. To import IO exception. In a few weeks, after 2 weeks, we will discuss about exceptions. Okay, but for now, and for instance, ArrayList. You see the ArrayList? It is getting error. Okay, for the ArrayList, actually Java, there is a utility package in Java. So that package has the ArrayList class. Okay. So you see the ArrayList, I need to add those packages. Press Control +1. You see that import ArrayList from java.util from Java util package. I need to add ArrayList. Just double click. The ArrayList is added, and my program should be fine. My program should be fine. If I save it, it should be fine. Okay, so an ArrayList is a very simple. So ArrayList has some built-in operation like add operation. Okay, some add operation. There are some for each operation like remove, contains, remove, and with an index, or sublist, get. There are some size. There are few, like you say, about 20 or 30, maybe about 30 built-in methods. All these built-in methods can be used to do array operation in dynamic array. The advantage of dynamic array that you don't need to fix its size when you declare. I'm not sure where is there coming from. Okay, it's gone. You see that this is the declaration of array list. My array list. This is a dynamic array, and you see that this is the array list type, built-in type. Okay, and then after this built-in type, you see that there is angle bracket, and within angle bracket it says integer. I is in uppercase. This is another class. This is a type. This says that it's called generics. Okay, so spend some time to understand collection and generics. Okay, this is not included in your syllabus, but I recommended that it should be included in this course, or at least in previous course. Okay, this means it's called generics. Generics means that, for instance, it restricted. It makes a restriction that this array li, this is a list, right? This list will contain only integer type value. Okay, only integer type value. It will not contain any string type or for Boolean type or other type, non-integer type value. So this makes the restriction. Okay, so actually it is called restriction, but in programming languages people say that generics. Okay, so instead of generics, the word generics does not make sense to me personally. I like to remember it as restricted. Restricted means you cannot have other type of value. You see that without, you see, add ArrayList, add I. So for instance, if you want to do like this, ArrayList dot, there is an add method. Add, you cannot do that. For instance, you cannot add a string. For instance, you cannot add a string because it will be giving you compile time error. So this generics, it ensures that you will not be able to add any other kind of data in this list. You see that if I do not give the restriction, then it is allowing me to include other types. Like for instance, this is a string type, right, within my list. But this list is, I'm expecting to put integer type value. So if I have 1,000 elements, all integers, but if I have one value by mistake non-integer, then if I need to do a sorting operation or searching operation or average, find the mean, median, mode from this array, I will get an error, right? Because you cannot add a string with an integer number. You cannot get an average, right? For mean, media. So this is why, if initially, when ArrayList was first included, that there was no restriction, but then people saw that that people were doing mistake in some time unintentionally. Okay, so then they added the restriction that is called generics. Then when I add generics, then it will not allow me to non-consistent type. There are some few methods like add and then remove. Okay, add and remove, a few methods. So please spend some time to do this, to understand this. Very simple. I think if you spend one day, then you will get some time in one day, then you will get some idea about this ArrayList. Okay, everybody please spend some time to understand. Yes.
When you add elements to the array list, does it copy the entire array over in that?
No, ArrayList actually it adds to the list dynamic array.
So it's like a linked list?
Yeah, like linked list. So we will discuss linked list. Linked list is one step ahead of ArrayList. Okay. So actually, this ArrayList is linear type, and linked list, what we are going to discuss soon, that is actually for non-linear. Okay, so that what is the take-home message for now? That please learn about Java collection or C# collection and array list, that means dynamic array, by yourself. It is not hard at this point. Okay, it's easier because there are some built-in methods. For instance, the size, it returns the number of elements in the list. And then for each of these, I think if you go to this side, then for each one, maybe you will see a program. Maybe they have given a program. So if you click each of the list, then you will get actually a demo program, and then you can practice. But if you do not understand something, if you need help, please let me know. Okay, so although ArrayList may not be in your test, but I am asking you that you should know this. In order to learn programming, you must learn this dynamic array. Okay, and then now we will go through linked list. Okay, so that it says that list and not in plural. Okay, so then I will tell you why this is plural, and it's called linked. So what it means by linked? Linked means a list. A linked list actually a dynamic data structure. Okay, and linked list is like a chain. Okay. For instance, in the chain, each element knows who is next to that element. Okay. For instance, think about that, when you are sitting on a row, when you are sitting on a table on row, so how about if you only focus either on left side or right side? Let us think that only for if you make friendship to the next person, right side to you, then he will make a friendship, he will know who is next to him, and he will know who is right to next to him, and he will know who is next to him, right? So in that case, so everybody will know who is next to him, at least. Okay, and in that situation, the elements or nodes or the people who are middle, they know two things: who are before him or next to him. Okay, so this way all elements are linked to each other. Like, think about a situation like this. For instance, here. Okay, so for instance, so here we say it's called node. The main element component of a linked list is called node. A node contains two things. One is data, and another is the address of the next node. You see here, this is a recursive method, recursive call. We understand recursion, right? We discussed recursion. When a method calls itself, that is called recursion. All linked lists work in recursive fashion. So the main component of a linked list is called node. Okay, a node contains two things. A node contains two things. One is data. Okay, one is data, and another is the link. Let me redo it. Actually, okay. So this node is the main component of a linked list. Okay. So a node is like this. A node contains two things. One thing is data. The data can be any type. It can be an integer type, it can be float type, it can be boolean type, it can be an object type, okay, class type. And the link, the address is called link. I'm sorry, data and then link. Link call is the address to the next element, next node. Okay, for instance, if I have a first node, node 1, each node contains two things, remember that, okay, some data and then link address of the next node, okay, and then 2, and then for instance 4. Then this is my starting node and it will be linked with the next element. So the node 1 will know its data, what data it has, it contains, as well as who is the next node. Okay, so the next node is 2, and 2 will know who is the next node. 2, okay, who is the next node to it? That node number 4 is the next node to it. And this way it will go. So this is called singly linked list. Singly linked list means that one node contains only data. Every node contains data and the link of the next node. Okay, for instance, these two, second node, it knows who is the next to it. Okay, and then number 4 is the last node. Then if it is last node, then it knows it is last. That means it knows that last element is null. Null. Okay, and now for instance, if I need to add one more node over here, you can add a new node at the beginning. It is doable. You can add at the end, and even you can add a new node in middle at any point. For instance, if you want to add a new node, node 3 here, in between 2 and 4, then this link will be broken. This previous link will be broken. This previous link will be broken. Okay, or deleted, then it will create a new link with him. So 2 will know that its next node is 3, and then 3 will know that its next node is 4. This way it will be reorganized. Okay, so for linked list, and there is, it's called singly linked list. It is called singly linked list. Linked list, and there is another kind of linked list that is called doubly linked list. For doubly linked list, some elements, like for instance middle elements know who is before it or who is next to it. Singly linked list, in singly linked list, each element knows who is only next to it. Okay, but there is another kind of linked list that is called doubly linked list. Doubly linked list in doubly linked list, all the middle elements, okay, all elements know who is before it and who is next to it. So for doubly linked list, there are two link address. One will be this side, previous, and this next, and then data. So there are two kinds of linked list. One is singly linked list and another is called doubly linked list. Okay, this is why the title says linked list plural. Okay, now you understand why do we call linked list. There are two kinds of linked list. One is singly linked list and another is doubly linked list. So the main difference between singly linked list, that a singly linked list, it contains data, any kind of data, and it will contain, okay, then you see that it's class node, and node class is calling itself, is recursively. Okay, so then it contains the next address of the next element. Okay, and for doubly linked list there will be two. One is next node, another is previous node. We will discuss doubly linked list later. For now, let us go through singly linked list. Okay, and for singly linked list, for instance, this one. Okay, for instance, this one. This is let me go through more. Here is 15 is data, and it is contains the links of the next node. And you see that there is a tiny crossbar over here. It shows the null. The next, there is no next. This is the ending point. Okay, so for linked list there are some common operations. We need to understand this. Okay, so this is the insertion. Insertion are two kinds. You may insert at the front of a node, or you may insert at the end of a node, an existing node. Okay, or you may insert at the in between two nodes. Okay, you may to, for instance, if an initial list is empty, then you need whatever you will insert first, that will be first element, right? Then if you have already one element in your list, for instance, if you have already one element, this one element in the list, then think about that. If you want to add another element with this list, okay, you have to consider where you will be added, in the front or in the back, right? So if you want to add in the front, then you need to do like this way. You need to add here number 2 here, and then you need to link that with this one. Or if you want to add after, for instance, node 3 here, then you need to add like this way. And think about that, if you want to add in between two existing nodes, okay, then the operation is kind of different. And similarly for deleting, you may need to delete the top one, right? For instance, if you want to delete the top one, then what you need to do? You need to delete the top one, you need to delete the link, and you need to make it head at the beginning. Similarly, if you want to delete this one, yes.
I just want to ask, the first node in a linked list, does it have null data?
No.
Okay, I was.
First node will have data. Every node is supposed to have some data. So the last node may have null address. For the next one, next address is null, maybe. Next link. So nothing. This is the end point. We will go through this the live program. Okay. Or think about that. You may need to delete. You may need to delete an element. For instance, if you want to delete the element this node 1, so then what will happen? If you want to delete this one, so then what will happen? You need to delete one. Then you need to delete this link, you need to delete this link, and you need to link this with from here to there. So really these are tricky operations, but if you understand the main concept, then it is doable. Yes.
Is it possible to delete a link if it's just single link?
Delete everything?
Yeah, is it possible to like delete a middle link if you don't have previous and an X?
So there is no middle. So if there is no person next to you, so you are the top, right? So that we are considering that it is singly linked list. Okay, this one you are the element. You said there is no one in your list, right?
No, I'm saying if you have, so you have Todd and then
Okay.
but it's just a single link list,
Yes.
not a double link.
No, we are talking about singly linked list. Yes.
Is it possible to still do deleting with that?
For instance, this one, the top one, two. Yes. If you delete this one, right, then what you have to do? Then you need to make who is next as the top.
How do you know which previous?
This is for the top. There is no previous. Previous is null.
Asking how do you delete on the middle one?
We will go through. Thank you for your curiosity. Let us go through dive into a program. Okay. Okay. So we need to understand first insertion, then deletion. Then, for instance, we need to understand searching as well as searching and sorting. Okay. But for now, searching and sorting is difficult. So we will do insertion, deletion, and searching. Okay. So the insertion method. So insertion method, it performs the following steps. Okay, these are the pseudocode. Okay, so if I read aloud this, I don't understand anything actually. It doesn't make sense maybe for you. Okay, so instead of read aloud these stuff or memorizing this, let us understand through a live program. Okay, and then in C# and Java almost same. Okay, so linked list operation, C#, and so we have insertion operation, deletion operation, and then we have what are those? You see that there is in this slide there are some like this is a pseudocode type or the steps, and it has some code snippet. That means these code are not complete. If you try to run this code, it will not run. Okay. Then what you need to do, actually, this code, instead of going through each of this code, I like to go through a live program that I want to discuss how linked list works. Okay. So this is really tricky thing. I'm telling that this is really okay. Let me copy linked list to your section. Linked list. This is not right. Let me copy it so that you can get it. What is it called? Linked list. Okay, so it has linked list exercise 3, singly linked list, and singly linked list, and doubly linked list. Okay, so for today we want to go through singly linked list. Okay, so I have a complete program. If you run this program, I think last semester I discussed this, and I think it should work. Okay, that's good. Okay, now instead of going through this, running this program at a time, I want to explain from the top to the beginning. Okay, and let me go through. Instead of doing this, okay, let me cut this program entirely and put in a text file and copy and paste part by part. So whatever we understand, let me copy and paste. Okay, instead of putting all together. Okay. Okay. So the heart of this linked list is called a node. You see that I discussed maybe from the beginning that this node class is the heart of a linked list. Okay, so let us make it maybe public class. Okay, instead of this. Let me copy from here. Actually, I don't need so I don't need public. Class is fine. So this is the heart of a linked list. So let me copy this class and let me put it here. Okay. So in C#, you can write in S is in lowercase or uppercase. Java is S is in uppercase. Okay. So far this program is good, right? So this is my node is the heart or main component of a linked list. Okay. So everybody please give attention. Yeah, if you want to stay in this class, then give attention. Otherwise you will not understand. You will not, if you do not understand today's note, then you will not understand next week, the total next few weeks. You will not understand. This is the foundation. Okay, so then a node, as I mentioned, a node contains two things. One is data and another is the address to the next element. How the address of the next element is stored? By using a recursive call of the next of the same node. You see, this data can be any type. It can be a string type, it can be an integer type, okay, it can be any type. Okay, so in my program I wanted to discuss with two kind of data. For instance, instead of doing this, let me try to add one is integer type. Okay, sorry, one is integer type and another is string type. Is ID, so I'm adding both type, both ID and name. Okay, so if you understand how to handle integer type and how to handle string type, then you should be able to handle or add other component, other elements. Okay, and my node, my node, this is a node to next. I can make it default, or I can make it public, or I can make it not private. Let us make it either I can keep it public, or for make it simplicity I can make it default. Okay, so far is good, right? Okay, then this is my starting point. Every node will contain three things here. Actually, this is in data. Actually, two things. These are data and this is the next node. So data is I have in data part through ID and name, right? So that means each node will contain three things: ID, name, and next node, address to the next node. Okay, so then in order to put ID, let us have a constructor of this class. How can we declare a constructor of this class? Public. Can we have a return type of a constructor? No. Okay, thank you. Okay, so integer ID and then string name, this dot ID equal to ID, and this dot name equal to name, right? So far is good for the constructor. Okay, so same thing I do have. Actually, let me copy these parts. These are the comments, so that you know what are they. Okay, so this next node is reference to the next link, okay, made in the linked list. Okay, it holds the reference to the link that was created before it. Okay, so these are just comment if you need to understand why I'm using each of these elements. Okay. Now, for instance, if we want to have a display a node, so if we want to have, for instance, we want to have a method to display a node, only one node, display one node. So for instance, we want to display this way. Okay, system.out.println id equal to id, name equal to name. It will just let us add this method. This will help us to display only one node. What it will be displaying? Both id and name, right? It's very simple, right? Is there any complexity in this method? Everybody should know this, right? Everybody is okay so far? So let us again, okay, so this is very complicated, okay? So if you do not understand from here, so then step by step we are going to in difficult part, okay? So you need to understand. Actually, I want to make it in one line so that you understand this. You can see. Okay. So whatever so far we have a node class and we have a constructor, right? The constructor is we will use this constructor to add an element to this one. Add ID and name to a node, to a linked list, okay? And then we have used this method to display ID and name. So far it's simple, right? Okay, that's good. Now I need operation for what? I need operation for insertion, deletion, or something. Those kind of operation I need. So this one is here. This one is here. Okay. So now I need operations. I need to do some operations on this linked list. So in order to do some operation on this linked list, I can write all of my codes in my main method, inside my main method. Okay, so actually I should have this singly linked list class, right? So this is the file name. I should have a public class like this. I deleted this part. Actually, let me bring that. This one. So actually I should have this one. So this is, since this is my actually I should have this one, right? This is my public class, is saved this way, and I should have a public class, the name as the file name. I deleted from there, I brought it here. Okay, and then I should have a main method, right? So far I do not have any main method. So let us get the main method format. So this is my main method. Okay, so then whatever so far I have the structure. I have a node structure. Okay, and then I got node. Then what do I need to do? I need to create a linked list, and I need to add nodes to the linked list, right? Let me go through this code. For instance, I have node over here and I have my main method over here. So far, if I say I need to create some node object, if I say node in1 equal to new node, maybe I can say it 1, and then I can say A. Is it good? So far this is good, right? I have created a node right? I have created a node class. Here is my node class, and then I am creating object, node object. I can create as many nodes I need or I wish. N1, N2, N3, N4, for instance. N1, so let me do N2 and then put ID equal to 2, and then let me put it B, and this is C, and this is N3 and N4, and let me put it D, let me put it what is 3, third node and fourth node and fifth node and E, and I need to make 5. So far it's good, right? What I have a node class, and I have this one, and I have a node class, and I have created some object of this node class. Like so far whatever I did, I have like this. I have node N1, I have N2, I have N3, I have N4, I have N5. Okay. Now, for instance, so far is easy, right? Anybody has any complexity understanding so far? Everybody is good? Okay, please give attention. If you do not understand, please raise your hand. I will go back. I will review. Okay. For that is very important for the next 15 minutes. Okay, give full attention. Okay. So you see that if I have this node just created, this node is scattered. It is waiting in computer memory. It is taking some place, but I don't know where it is taking place, where these are taking place. But these nodes are distinct. None of these nodes knows who is next to it. Okay, for instance, then if I want to do, for instance, N1 dot, you see display, I have a method, right? Display a node. Okay, and for instance, I do N2 dot display node. If I do N3 dot display node, I do N4 display node, I do N5 display node. Okay, you see my program is so far is good. If I run my program, okay, then it's good. It is displaying. It is displaying for node 1 ID equal to 1, name equal to A. For node 2 ID equal to 2, name equal to B, and node 3 ID equal to 3. Output is okay. Output is okay, right? Okay, but the problem is that each of these nodes does not know who is next to it. These are not linked together. These are scattered, independent, right? So I need to write some methods. I need to write some methods within my, either in this class, maybe in this class, or within this class, or within main method, or I need to create another method. For instance, if I want to, let me show you. Okay, before that, okay, so I claim that these nodes are distinct, independent. These do not know who are next to them. For instance, if I'm saving time, for instance, okay, in order to save this time, if I do this, okay, I don't have 6 element. And 6 will be, for instance, F, and then 6. Okay, the program is good. If I run this program again, then what it will show that every node, if I say n1 dot next. N1 has a property next, right? N1 has a property next. You see the next? Every node has a property next, right? But this property next is showing that null. It says that n1 dot next equal to null, n2 dot next equal to null. Every node's next element is null. But apparently, actually, we know we should have only the last element next should be null, and we should have n1 dot next equal to a. N1 dot next equal to n2. We should have this. Like actually, when we complete our program, it will show like this way: n1 dot next equal to n2, n2 dot next equal to n3, n3 dot next equal to, for instance, n4. Like then this will be linked. So then, in order to link these nodes, we need to write some codes. That code may stay within this class, okay. You know that one thing that in object oriented programming like C++ and Java, you cannot put any code, there cannot have any orphan code. Orphan means that you cannot write any code over here within a class. All codes go within a method, right? You have to put all of your program codes within a method. You cannot put a code scattered within a class. Within a class, you can just put either variable or method, declare method, okay? So all individual code, even if you want to print something. For instance, if I want to print hello, can I write here? Print hello. Can I write here? No, I cannot write here. Within a class, this is called orphan code. I cannot put here, okay? So this code needs to be put within a method. Okay, so that what I'm telling is that in order to link each node with another node, or inserting a node or deleting a node, we need to write some codes. Okay, that codes can be within some method within this class or within this class. Right? We can put some methods within this class or within this class. In general, that can be, but if we put all of this method within the main class, this is my main class, the program will be clumsy. So that instead what people create a class, different class, it's called class linked list. Okay, then they create a class linked list by name linked list, and they put all of the methods within this class. Insertion method, link method, delete method, search methods, all of my methods or operation, linked list operation go within this class. Okay, so then let us see. So this is my link class linked list. Okay, sorry. Okay, this is my linked list, and let me show you. Just I have few more minutes, so I'm copying and pasting some codes. Okay, so within this linked list, I need to put the one node is called head. Oh, sorry, NK, right? Oh, this is why it's making. Okay, thank you so much. Okay, so this class, thank you. So this linked list class, okay, it has, I need to put a node. A node type element is called head. Okay, and this is what is this one. This class will have its own constructor. Okay, so this constructor will be used. So if head equal to null, that means initially when you create a linked list, then its head will be null. Okay, I will tell you why do we need this one. Okay, and for instance, if my list is empty, then we will say if return. I will go through this. Okay, so then what is the advantage of using this linked list? Is that, let me go through. I will not be able to finish this tonight, but I want to stop in a point so that we can finish in our next there are too many codes. Okay. So I will explain you. Okay, so this code this code I will explain you. Okay, so but for instance, let me use this linked list class. How can I use this linked list class? I need to create this one. I don't have this type. For now, forget about this. Oh, I did have this one, right? I did have this, and then I added. We need to add this one. We have a class is called linked list. Okay, so now we are creating an object of this linked list. Linked list, the linked list equal to new linked list. Whatever variable I can give, the linked list, whatever it is. Okay, so then whatever I did, that I just created a. This is my empty linked list. Actually, this is my linked list. Actual linked list. I'm going to create. Okay, so what will be the advantage of this linked list? Okay, so here you see, if I say, I will not be able to finish today. What I say? Okay. Okay, another thing that. Okay, one thing that I can quickly finish today. So there all linked are empty, right? All n1.next equal to empty, n2.next equal to empty. That what I can do, for instance, let me put this out, and then I can say, if I say n1 dot next equal to, when I do something hurry, then it becomes n2, and then n2 dot next equal to n3, and n3 dot next equal to n4, and n4 dot next equal to n5. For instance, I'm doing this way, and n5 dot next equal to, for instance, n6. If I do this way, okay, so after I linked, then now if I re-execute these codes over here after this, then what it will be printing? You see that before it was printing null, right? Maybe I can keep this code over here again. Now if I run this code, then it is showing me n1 dot next equal to, okay, so this is a good thing, linked list dot node at the rate this. Anyone understand this? What is this? This is a memory address, right? Yes. So why I'm getting this? Actually, I wanted to see here n1 dot next equal to n2, but instead of showing my n2 node over here, it is showing my address of the next to n2 node. So that means I have missed something, right? I need to override the toString method. Okay, I need to override the toString method. Let me see where do I have the toString method. This is very simple toString method overriding. It's very simple. In the node class, I need to override this toString method. You see the override toString method is very simple. I can have override. Okay. Now if I run it, okay, then I got something good. You see that n1 dot next equal to b, and n2 dot next equal to c, and n3 dot next equal to d, and n4 dot next equal to e, and n5 dot next equal to f, and n6 dot next equal to none. Because why? After n6 I don't have anything, right? Okay, so far I got that I know that how to link. Okay, but this linking is manual linking. So this linking is so that I have linked this manually. You see that I have linked what? I have linked n1 dot next equal to n2. This link I have done manually. So we need to write a program, complete program. So when we add a link node, the node will be linked automatically with its previous node. Okay, so in the next time we will see that we will not do this kind of manual linking. Okay, instead of we will complete this method, this class. We will complete this linked list class. So far it has empty. It does not have too much stuff, right? We will add other methods over here. For instance, if we add some other methods, here we see that in our next course we will see how to add. There are two kinds of append or prepend, okay, or remove or something. Okay, you see that if we add these methods, you see that there are some methods. Then if we add these methods, then after that we will be able to add an element, a node with another node that will be linked together automatically. Okay, so far whatever you have, okay, actually let me put my entire code over here in your project. Okay, so let me put my entire code in your project, and I am pushing this code in your GitHub account. So before you come to next class, please at least review so far I have discussed today. Okay, so in our next class I will start from here. Okay, and then I expect that I will complete in my next in one class. Okay, but if you do not understand that the simple task whatever I did so far, then these are the foundation. So next time what we need to do, we need to expand this linked list class. Then we need to add method for addition, insertion method, remove or delete method, or find or searching method. At least we will learn at least these three things. Okay, so I am putting this code, all of this code, to the GitHub account, and then get the latest code. Do you know how to get the latest code from GitHub? Okay, how many of you know how to get the latest code from GitHub? Yeah, don't shy, please raise your hand. How many of you know, and how many of you do not know how to get the latest code from GitHub? So for instance, if you pull my program a few weeks ago, right? By this time I have added some new programs in this GitHub. So your code is behind, your project is behind, right? With some codes. Then actually what do you need to do? I will show you later. What do you need to? Let me push this code. Git add git commit m linked list added, and then git, everybody has signed on the attendance sheet, git push okay. There is only one single line command you need to execute from your project in order to get the latest code, in order to download, in order to update your project or synchronize your project with my latest project. That is called git pull origin master. Only one line of code, okay, you need to execute. Okay, sometimes if you, okay, so if it says that already up to date, that means your project is already up to date. And if it does not work sometime, then you will put git push pull origin master /f. You can force it, then it will work. It must work. Okay, so then if it shows that already up to date, that means your code is up to date. Okay, get the latest code and then do some practice, and then in our next class we will finish this. Okay.